Morning MYP4. So just going through your lovely acid and base test. So the first question, draw a ring round the correct answer to complete the sentences. So hydrochloric acid is an acid, or is acidic because it releases H+ ions. And sodium hydroxide is alkaline because it releases OH ions. Each of those is worth 1 mark. Moving on, describe how the results would show that ethanoic acid is weaker than hydrochloric acid. You essentially just needed to explain what they would do with universal indicator. So that was a key point. This is universal indicator, not another indicator. So ethanoic acid goes yellow or orange, whereas hydrochloric acid goes red. It's not a paler red. You would need both of these for the 2 marks, 1 mark for each of them. A paler red would not get you a mark because the universal indicator goes different colours. Next one, draw a ring around the correct answer to complete the sentence. So strong acids completely ionize, or you could also use the word in a different question, obviously not in this question, dissociate. So strong acids completely dissociate. Again, drawing rings around the correct words. So this, you should know, is a conical flask, and this is a titration. The total marks here is actually 2 and not 3. Part B suggests one way to make the results more reliable, and that's repeat and take an average. Okay. So reliable is essentially average. If it was precise, this would be use more equipment with a smaller scale. And that's the difference between accuracy and precision. Question 3, this was sulfuric acid. You needed to form a sulfate. So to form a sulfate, we obviously need sulfuric acid. And yeah, that's essentially it for that question. And finally, then draw the formula. Now, SO4, you should remember, is 2-. Just make sure you do know that. And sodium is in group 1, which means it will have a single plus charge. So to balance 1 positive with 2 negatives, we need 2 of these. Okay? So it's Na2SO4. Now this little 2 after here is basically means the element before it, just the first element. Whenever you want to double up multiple elements, say for example with if this was magnesium hydroxide, we use brackets to include both the oxygen and the hydrogen. This 4 here only applies to the oxygen and not the sulfur because it's not within brackets. Question 4, sodium nitrate. Now going back to charges again, nitrate is negative. Sodium, as we already established, is positive. That's a single positive and a single negative, so they balance perfectly. However, as we already established, a sulfate is 2 negative. Potassium is also in group 1, so it will have a single positive charge. To balance a single positive with 2 negatives, I need to times that by 2. So hence why you have the 2 here. Obviously the words, I think most of you got the words correct, sodium nitrate, potassium sulfate. It's just getting these chemical formula correct. It's important to note as well, when getting chemical formula correct, you're not going to use big numbers like this. in front of. This is purely for balancing equations. Chemical formula will include small numbers next to the elements and brackets. Question 5. The reaction is heated in stage 1, suggest why. Speed up the reaction, that's why we're heating it. How do the student remove the unreacted copper oxide? We'd filter it or decant. Decant just means to pour off the top, but filtering is obviously the better, and that's worth 1 mark. How would the student obtain copper sulfate crystals? So they'd crystallization or evaporation, heating or boiling. So you did this reaction. So this is a solution, which means we've got salt and water. In this example, the salt is copper sulfate. Now, how do you get copper sulfate from that? Well, we obviously need to remove the water, and to do that, we can boil that off, and that will leave behind the solid. Okay, so in this question, the solute, using the correct terms, would be the copper sulfate. The solvent, i.e. the liquid it's dissolved in, is water, or H2O. And the solution is both of them together. So salty water, essentially. And if you just want the solute, then we need to remove the water, and the easiest way to do that is evaporation, heating or boiling. Next question, complete the equation. So this is H2SO4. You should be familiar with that, but hydrogen is pretty much always going to be a H+. Again, we need 2 of those to balance our SO4 2-. So H2SO4, and water is the other product for this neutralization reaction. The mass of crystals obtained was less than the student had calculated. So essentially this is lower than he thought, and this could quite simply be that this wasn't a complete reaction, so incomplete reaction. By that I mean all of the copper oxide wasn't reacted, or all of the, actually sorry, more precisely, more of the sulfuric acid wasn't reacted. So not all the acid reacted would be the alternative. You could have also said some of the salt was lost in filtering or pouring. So this process here, when we were boiling it or when we filtered it, but you did have to be specific. You couldn't just say lost in method. You had to say where. And it could also be a weighing error. Question 6. Now this is one a lot of people struggle on. This is a follow-up question from question 1. What is meant by a strong acid? It completely or fully ionized. That's worth 1 mark. And then when dissolved in water is the 2nd mark. So all of acid and alkali chemistry, or acid-base chemistry, happens in water. Water is a very useful solvent, and it can dissolve lots of different things. Write the ionic equation for this neutralization reaction, including state symbols. So neutralization will always be H plus OH minus goes to form H2O. To write this out fully, we would have had 2Na plus 2OH minus plus 2H plus SO4 2 minus goes to form 2Na plus SO4 2 minus plus 2H2O. And you can remove spectator ions. So what I mean by spectator is ions that haven't changed their charge. So the sodium, as you can see, hasn't changed its charge, so we can remove that. The sulfate hasn't changed its charge, so we can remove that. Whereas because we formed 2 water, these are no longer charged, but they came from a positive H plus and a negative OH. So that's where the equation comes from. So we remove spectator ions. If you wrote out everything that you saw in green, I would have still probably given you the marks. But a lot of you didn't separate. You would have left left a little 2 here, okay? And when you're separating them out, obviously we need big numbers in front of. So when we remove all the spectator ions, so ions which haven't done anything other than they've stayed the same, you are obviously left with the equation that you see. 2OH minus plus 2H plus goes to form 2H2O. We could obviously remove the 2's because they all balance, and you're left with this reaction. Aqueous, and liquid was the second mark. So mark 1 for the equation, mark 2 for the state symbols. So start to get into the practice of state symbols. Just to recap, solids, liquids and gases. So you have solid, liquid, gas. They correspond to S, L, G. AQ is aqueous, which means dissolved in water. Generally speaking, ions will have, these are going to be aqueous most of the time. So they will be dissolved in water. If they're not ions, well, yeah, generally speaking, if you've separated them out, they're going to be AQ. Moving on. So question C. You should have all been able to get this. I gave you an example of this type of question. And I said it would be worth 4 marks. So this is carrying out a titration. So first of all, 1 mark. So mark 1, add an indicator to the NaOH. You need to name an indicator, and this could not be universal indicator. We don't use universal indicator in a titration because, big no-no, because it doesn't have a clear color change. Universal indicator gradually changes from red to yellow, red to orange to yellow to green, and so forth. It's not used in titration. Then acid in a burette is added. So you needed to state the name burette. You understand that piece of apparatus, and the acid is going to go in that. You know which one goes in the burette, given that the question has said pipette 25 centimeters cubed to a conical flask. So what that is telling you is the sodium hydroxide goes into the conical flask, meaning the acid must go into the burette. Okay. Third mark, swirl the flask or add dropwise until the indicator changes color. This is essentially saying add it slowly so that you can see the clear color change and you haven't added too much acid. And then finally is to state the indicator color change. So for phenolphthalein, which you're best off just remembering that one, pink to colorless. So it is pink in NaOH and it is colorless in acid. You could have said another one, say methyl orange, and if you had the correct color change, that would also have been accepted. Finally, I think only one of you got this question correct. I can't remember who it was. Most of you got error, so if you saw ECF, that means error carried forward, which means if you did the first point wrong, but still did the calculation, you would have got the second mark. However, if you read the question, which most of you did not do, as in 99% of you did not read the question, it said, use the student's concordant results to work out the mean value of 0.1 sulfuric acid. It also said, concordant results are within 0.1 of each other. See this statement here? It is telling you how to answer the question. So you had to look for the ones which are in 0.1 of each other, and that's those 3. You would remove these because they are not within 0.1. And this is standard practice as well, which you did in the titration. So you take those 3, divided by 3 gives you 27.12. Please do note this is centimeters cubed. Is your equation 2NaOH plus sulfuric acid. So calculate the concentration of sodium hydroxide, give you answer to 3 significant figures. So it has specified 3. So here is the calculation, and I'm going to set it out again in a table. But essentially, your first thing is moles of H2SO4, and this equals 0.1 times 0.02712, and this number is the same as this one. Okay, all that's happened is you've converted centimeters into decimeters cubed. So essentially you divided by 1,000 to get it into decimeters cubed. Okay, so divide by 1,000. The 0.1 comes from, so this value comes from the question here. It gives you the concentration, because this says moles per decimeter cubed, so it's a concentration. So you know the concentration and you know the volume, therefore you can work out the moles, and this is the moles of H2SO4. Finally, the ratio, it's 2 to a big invisible 1 there, 2 to 1. So for every 1 H2SO4 we have 2 NaOH, so therefore moles of NaOH is this one, so this number times 2, as you can see here. So if we times that value by 2, we get 0.00542. So your marking points, that would be 1 mark. Mark 1 is for that. Mark 2 is for the ratio. Mark 3 to work out the moles of NaOH. And then finally, once you know the moles of NaOH, we can now work out the concentration of NaOH. And this is going to be divided by the volume. And this volume here, 0.025, is generally always going to be 0.025, and that is because it is this value here. Okay, so you pipetted in, as in the conical flask, there was 0.025. Again, converted from centimeters cubed into decimeters cubed, which gave you a final mark for 0.217. If you wrote 0.2168, you'd have only got 3 marks because you haven't given it to 3 significant figures. Okay, just explaining that question again, but in a table form. If you did not understand that, please carry on listening. Those of you that understood it, you can skip a little bit to the next question. So a little bit more visual way of remembering this. We had 2 NaOH plus H2SO4 goes to form Na2SO4 plus H2O. Now we're not too bothered about the products, so I'm going to leave them off to this side and ignore them. But what we do care about, and the way I've shown you in class, is drawing a table underneath these two. And then down the left hand side we can put, initially we've been dealing with volumes, so liquids, so we care about concentration. So down the right hand side I'm going to write moles, volume and concentration. Then you want to fill in the values that you know. So this is 0.25 centimeters of sodium hydroxide, so that is a volume. So this is 25 centimeters cubed. The question asks you, calculate the concentration of sodium hydroxide. So that essentially is going to be a big question mark here, because that's what we're trying to find out. Then a titration, you have this value, 0.1 as the concentration of sulfuric acid. So we can put that in here. That's 0.1 because it says a mean value of 0.1 moles per decimeter cubed of sulfuric acid. So you've got to decipher the question a little bit. And then the volume of acid, which is calculated from the first question, and that's 27.12. I'm just going to write these in red. Now that's also centimeters cubed. Okay, so we've got most of our values. Now for sulfuric acid, we've got two values, so I can work out X. First of all, we want this in decimeters cubed, so I'm going to divide it by 1,000. Okay, and that gives you this value. Yeah. So we just move the decimal place 3 spaces. What was the value again? 2712. 2712. And I'm going to convert this one as well. And so that's 0.025. Let's do that one in blue. Okay, so first of all, let's work out X. So moles of H2SO4. This equals 0.2712 times 0.1, and that gives you the value that you can see there. So I can now replace X with 0.002712. And the ratio is a big invisible 1 to 2. So this, the moles, tells you the ratio that they're in. So the equation, if this was 2 moles of NaOH, you'd need 1 mole of H2SO4. But we don't have 2 and we don't have 1 mole. We've got much less than 1 mole. So figure out the ratio, you just times this by 2. And that gave you the value 0.00542 that you can see down here for Mark 3. And then now that you've got these two values, you can work out the final, which is obviously 0.217. Just a little bit more, just to help you out a little bit more, that value there is obviously going into the conical flask. So that's 25 centimeters cubed of NaOH, and you then had a burette. Which was filled with H2SO4, and the concentration of that is this value here, which was at 0.1 moles per decimeter cubed. Okay, moving on to the next question. The student did another experiment, so a different one. Okay, so this didn't apply from the one before, with 20 centimeters of sodium hydroxide at 0.18. So to work out, and it says calculate the mass. So here is your sort of mole highway where we've got concentration, we've got moles, and we've got mass. Now you can't go from concentration to mass. You can't do it. You have to go via moles and then to mass. So the two equations that you needed were the one from before, concentration equals moles over volume, and you also needed mass equals moles times mR. So the first one would be 20 divided by 1,000 to obviously make it into decimeters cubed times 0.18. That gives you the number of moles, which is 0.15. And then the second equation, the MR of NaOH, it tells you is 40, and this equals 0.144. To go through that again, your concentration we were given, so moles equals concentration times volume. This is 20 centimeters, but we're going to divide that by 1,000, okay, because this needs to be in decimeters cubed, and our concentration is 0.18, and that gave you 0.15. And then the mass, now that we have the moles, this can go into this equation, 0.15 times the MR of NaOH, which is 40, and that gives you 0.144 grams. Okay. Okay, question 7. What type of compound is a metal oxide? Well, it's not an acid, so it's a base, given that this is an acid-base test, and that was worth for 1 mark. Then these, you should have all been able to get these because all the answers were there for you. You just had to decipher the information. This is that problem-solving style question. So name a soluble compound that contains silver ions. So soluble compounds, all nitrates. So silver nitrate is going to be soluble. Silver is a metal, as I'm sure you know. So you couldn't have silver potassium or silver sodium because both potassium and sodium are also metals. So silver nitrate. You also couldn't have said silver chloride, bromide or iodide, given that silver and lead are not soluble, because it said except those of silver and lead. Name a soluble compound that contains carbonate ions. Well, carbonate is non-metal. So the other half of that compound is going to be a metal, and given that it tells you that all potassium and sodium salts are soluble, you just needed to use potassium or sodium for 1 mark. Moving on, lead nitrate solution is prepared by reacting lead oxide with nitric acid. State how lead nitrate can be obtained from lead nitrate solution. So lead nitrate is soluble, given that all nitrates are soluble, as it said in this question. How can you get a salt from a solution? Again, this goes back to the solute, solvent, solution. So our solute in this case is lead nitrate. 90% of the time that solvent is going to be H2O, and they form, again, like a salty water. If you want to get rid of the water, obviously the quickest way is to evaporate or crystallize, boil it off, and that's just worth for 1 mark. Then balancing the equation. Now I saw a lot of students adding little 2's here and brackets. Never do that. This says balance. You are not changing the chemical formula. You can't add a little 2 there or a little 2 there. When it's balancing, it is only big numbers in front of the compounds, like that. You cannot change the chemical formula. So these small numbers and brackets make up the chemical formula. Pb in this instance has a charge of 2+, oxygen is 2-. They balance perfectly, so they form PbO. If you were to add a little 2 there or a little 2 there, then you are unbalancing or making it chemically unbalanced, because you now have 4 negative and 2 positive. So it overall is 2 negative. They need to be chemically neutral when they react. So 1 mark just for the 2 there in front of the HNO3, as we've got 2 nitrates there and we've got 2 hydrogen here. We needed to double them both. All important to note that that little 2 only applies to what's in the brackets. Okay, I'll say that again. This little 2 applies to what is in the brackets. You don't have 2 lead, 2 Pb. Give the total number of atoms in the formula PbNO3 so this is Pb, and then we've got a nitrogen, we've got 3 oxygens, but we've got 2 lots of this, so we have this. And so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 is the correct answer. Next question, write a balanced symbol equation for the reaction of dilute hydrochloric acid with calcium carbonate. This is worth 2 marks. So 1 mark 1 is for everything that is in red. Let's make that a little bit easier. That's mark 1. Mark 2 is for putting the big 2 there. Make sure you get chemical formula correct and then balance. If you can't balance, don't worry. But what is important is you get the chemical formula. This chemical formula you could work out. Calcium is in group 2, so it has a 2+ charge. Chlorine is in group 7, so it has a single negative. How do I balance a single negative with 2 positives? Well, if I double this up to give me CaCl2, it will be chemically neutral. Okay, just to show that again, 2 plus a Cl and a Cl. Overall, if I add these charges, it is 0. Okay, if you just put Cl, then it is unbalanced and we have a chemical which has a +1 charge. Describe one difference between the two reactions that you would see. A lot of you wrote carbon dioxide. You can't actually see carbon dioxide, but what you would see is fizzing, or a better word is effervescence, for 1 mark. Okay, you cannot see carbon dioxide, so you can't just say that. If you said gave off a gas or bubbling, that's also cool. Okay, question C. Describe how crystals of calcium chloride can be made from calcium carbonate and dilute hydrochloric acid. So first step is we're going to add some excess calcium carbonate and stir it and add, or you could have said add calcium carbonate until it stops fizzing. So essentially in a beaker you have some acid, which was HCl, and you could pour in, here's my little weigh boat, lots of solid. This is a solid, or supposed to be a solid, but it usually comes in powdered form. And this is going to be your calcium carbonate. As it reacts, it's going to fizz and produce lots of little bubbles. Okay, until eventually all the HCl is reacted, and then you'll just get some of the solid left at the bottom. When you see that solid at the bottom, you know the acid has reacted, it's all gone. It's important to note that sometimes it will take a little while, so you have to stir it. So then obviously we want the crystals of calcium chloride, so remove any excess CaCl3. So if you had the reaction Ca plus HCl goes to form CaCl2 plus H2O. If all of this is gone, but you're still adding some of this, finally in the beaker you will have this compound, and this compound. We only want this one, so let's first remove that, which didn't react because we used up all the acid. So that's step 2, is remove excess by filtering for the second mark, and then your third mark you could have said leave to evaporate, but what's better is you warm it. So we're going to heat this water up, okay, and then leave it to cool. So we warm it up until the crystals just start to form, and then when you leave it to cool, this water will then be removed as well and will help form nice big crystals of calcium chloride. Now you did this in lesson if you remember, so you just had to describe that process. So mark 1, add calcium carbonate until it stops fizzing, remove the excess calcium carbonate by filtering, so you did that process, warm until the crystals start to form, and then leave it to cool. On to our final question, question 9. Give the name of this type of reaction. So lead nitrate solution reacts with potassium iodide. Both of these are salts. Yeah, we can't see an acid, there is no H plus and there's no OH, so not acid or base. Both of them are salts, and this is a precipitation reaction because we form a solid. And if you form a solid, it's precipitation. Similar in geography, when gaseous water turns to liquid water, it's precipitation. It's called rain, where it goes from one state to another. In chemistry, that's when it goes from a liquid to, or aqueous to, a solid, that we call it precipitation. How is solid separated from the solution? Okay, how is the solute separated from the solvent? Now this is a solid, okay, and it's not dissolved, so filtration is fine. Since it's solid, it means it is not dissolved, so filtration, bit of filter paper and a funnel, perfectly fine. Write the missing status symbols. While the reaction was two aqueous solutions and we formed this solid, this is what we could filter off. Because they're in two different states, it's very easy to separate them. This one's a solid, this one's aqueous, so this will pass through filter paper, whereas this one will get left behind. Next question, lead iodide and iodide ions move through the water by diffusion. So you've got crystals of lead nitrate here and potassium iodide here. The final line is there, so what this essentially means is, the final line was here, wasn't it? So our Ki has moved much further than our lead nitrate. Okay, and since it's moved much further, it kind of gives an indication that this is possibly a smaller molecule, but we'll come back to that. What conclusion can you make about the speed or the movement of lead iodine ions compared with the lead ions compared with iodide ions? So the iodide is this side, the lead is this side. So here's the iodide, here is the lead. Since the iodide moved much further, they are faster moving. And your first mark, mark 1, iodide ions move or diffuse faster than lead, given that they got further. And that's a reason. Give a reason for your answer, because the lead iodide forms closer to the lead nitrate. Is that right? Yeah, lead nitrate. So X was lead nitrate. Or you could have said forms closer to the X. If you heat it up, what's going to happen? Explain in terms of particles. The particles move faster, so because they have more energy, they will collide sooner. They don't collide more in this place, in this instance, because they're on two sides, okay? And they've got to move before they can collide. So they will collide sooner since they have more energy. And that's the end of the test. Please go back through it. Any questions, please feel free to ask me. I will go through question 6 after school for those that want additional help. Thank you. Enjoy your day.